חברים, שמי לי הומס. אוקיי, נראה שזאת תהיה הרצאה מאוד קצרה, מפני שכרגע השתמשתי בכל העברית שאני יודע. חוץ מזה, וגם מזה. Oh, I can speak English. Great. Hello, everybody. My name is Lee Holmes. Today, we're going to talk about Azure Stack and some of the crazy stuff we've done at protecting and building the hybrid cloud. Now, the goal here isn't to talk about selling Azure Stack. Of course, if you want to buy one, that's cool. But we also want to talk about the learning journey we've gone and the things that we've done that have let us actually make some progress in this area. So how many people here are involved in securing customer enterprises or helping them do red team engagements and securing things, providing advice? Sweet. Bunch of defenders. So the first thing to think about here is the cloud. What has the cloud meant, right? So we've seen a huge shift. Customers are seeing a huge benefit, both security-wise and architecture-wise. The first step has been moving to the infrastructure as a service, where people are moving just the straight VMs and all that kind of stuff up into Azure. That's had a great security benefit because they no longer have to worry about the hardware. You don't have to worry about having the cages and all that kind of stuff. But where the security benefit has really started to pay off is when you started to say, we're going to start to build on platform as a service. So when I can start to say, I'm going to be using storage, or I'm going to be using just regular Azure websites. So for example, your Amazon S3 buckets are just that. Your Azure web apps are just that. You don't need to patch the SQL Server or the IaaS or the operating system even. The pinnacle of all this stuff is the software as a service. When you can just use the straight software itself and the straight websites, you don't even need to worry about the architecture or anything else. Now, here's the thing. Once you start to move all of this intelligence to the cloud, you can also do great specialization here. So you can say that, for example, in Azure, we have hundreds of people where their full-time job is securing the cloud, consistently red teaming, consistently looking at events, all this kind of stuff. They're building their professional reputation on doing this on an ongoing basis. So these opportunities, they let us move away from this general purpose operating systems and all this kind of stuff and start to move more into really thinking about resilient architectures that only do the exact same things that you need them to do. Now, of course, customers are getting very, very excited about this opportunity. But some folks, they have connectivity requirements. Maybe they have uniquely regulated environments, or they're just big iron. So let me give you a couple of examples of this. Take a cruise ship. We have some Azure customers where they've got a great Azure web app that they wrote. Now, the cruise ship, as it's going and doing its great cruises, is collecting data from their engines and their fuel consumption and all this kind of stuff. So what they're doing is when they get to port, they upload all this data to their Azure web app, and that helps them optimize their costs because running a cruise ship costs so much money. The reason that they can't do this when they're out at sea is because they have all these connectivity requirements, and you're not going to do this over just a simple, Wi-Fi network that's going over, satellite internet. You're just never going to be able to upload that data. Another great example is kind of the idea of proxies and facades. So you've got a lot of customers, think about an assembly line where this has been driven by a mainframe for so many years. Now, obviously you can't bring your mainframe to the cloud, but still you want to do something like, a modern interface to all this stuff. So customers, of course, they want to start doing these modern interfaces, and they don't want to go against these really bad terminals. So what you can do is with the same idea is with Azure Stack, do something like, you can write your local UI in all this modern fun stuff, and then have the network connectivity back to your mainframes. You can do the same thing when you're on a cruise ship where you don't need that remote internet connectivity. You can take that same Azure web app and bring it onto the cruise ship itself. So this is the genesis of Azure Stack. Azure Stack is very literally Azure. It's the Azure portal. It's the Azure ARM, the API surface for Azure. We've done a ton of stuff about making sure that it's consistent at both the portal level, API level, infrastructure level, all that kind of stuff. The one place where it does change is at the very, very bottom. Now, Azure has a cloud infrastructure. A great example is the DNS service in Azure itself. The very bare bones implementation of that is something like 1,000 computers for this multi-tenant hosting. The very basic storage stamp in Azure is something about 500 to 1,000 computers fully dedicated to storage. It's kind of a non-starter for somebody who wants to do this stuff on premises. So what we have in Azure Stack is a cloud-inspired architecture where we've done some things about building on basic Windows Server technologies and the stuff that you deal with on a day-to-day basis. Azure Stack has the stuff from Azure you'd expect from the infrastructure. So you've got compute, storage, networking, and all that kind of stuff. You also have the platform stuff that people are really starting to go. So you've got your Azure websites, Azure functions, and we're continually building this out. So it's really exciting. Customers now who have big iron, or they've got uniquely regulated environments, or they've got their cruise ships, can now take that exact same Azure experience and write something that works directly in their disconnected environment. So of course, the media is picking it up. We've got the analysts picking this up. So it's a big thing. And let me tell you, when the Microsoft financial statements and the earnings report are talking about Azure Stack, yeah, that's a little bit of weight on your shoulders, right? When you got all this, you really have to worry about security. So what are some of the things that our goals for Azure Stack are, right? So the big thing that we have with Azure Stack is we need to make sure that this is something that can stay consistent with Azure without people having to do a bunch of crazy, crazy stuff that we've had to have them do in the past with other virtualization platforms. So here's the thing. We've been down this road before. In the early days, we had Windows Azure Pack. So Windows Azure Pack was a thing based on the VMM and System Center and all that kind of stuff. You could download the Windows Azure Pack, install it, and it was cool. It did a great job for virtualization, but the big issue was it came with like a 60-page document on how to set this up. Customers start to read it, they kind of skip some of the security stuff, and it gives them some best practices, but you can't be sure it's going to happen. The other big thing with that early level of the virtualization play was hardware is always the issue. You try to do something great, but then you have hardware where you start to do some hardware offloading and then things just crash. So we had an answer here. The answer to this was CPS, or the Cloud Platform System. Does anybody recognize those words? Anyone try it? The Cloud Platform System was our attempt to really integrate this much more. So what you would do as a customer is buy the Cloud Platform System. That was then with some well-known OEMs, and then all the stuff was validated, and we tried to do an even better job at the documentation. Now that we knew more about the infrastructure, what we could do is to say, well, hey, this is exactly how to secure it. So this was like 300 pages of documentation. I don't know if that was like a good thing, bad thing, but we lost a lot of people on it. So lesson number one thing that we definitely learned here is I like cake. So when we were first going down this CPS path, we started to build this connected infrastructure that was able to do all this stuff for you, basically automated deployments, great design guidelines. Started to point out to some people that, hey, we're now building a complete wrapped system. We need to think about this from the perspective of what is the security of this whole thing. And you talk to some people and they go, well, we've done an amazing job at securing System Center. We've done an amazing job of pen testing and everything against the Windows Azure pack. And a lot of people thought that that was good enough. If, we're going to service those things, but the reality is when you're building one of these end-to-end systems, the connectivity makes a big difference. The act of shipping one of these things is like a chemical reaction that makes cake instead of something simple like just those ingredients. So we went out with Cloud Platform System. We spent a lot of time with a lot of customers helping them secure their environment. But the big lesson learned was, it was a gut feel in the beginning that building a system is different than securing its components, but it really hit home, and that was a big change that we made with Azure Stack. Now, when we start talking about, just regular architecture talks to smart people like you, this is how it starts. This is Azure Stack, this is the internals. Now, Azure Stack internals are internal. This is one major, major change we made. Azure Stack is not infrastructure. We have not one, but two major virtualization plays. If you're interested in the bits and bolts of exactly what storage you want and which controllers and what hosts, and are you going to do like SD versus whatever, there's a couple great opportunities for you. We had to make a very, very hard cut here to say that Azure Stack is not that. What we've instead done is made an integrated system. And this is primarily driven by the need for Azure consistency. People love about Azure is that it's always evolving, always improving, and is always growing. That's not going to be possible if people have made this bunch of random infrastructure where they're putting agents everywhere and doing their little things in all these different places. So we had to make some hard choices there. The hosts themselves are sealed. Customers have no access to the fabric. The hosts, the infrastructure, nothing. And what that gives us is really, really agile updates and refactoring. Does anybody recognize this episode from The Simpsons? Yeah. This is the Homer. So this was an episode of, Homer's looking to buy a car. He's just the average guy, right? And then you have all the people from the car industry saying, we're sick of doing these fancy cars that no one really gets. Let's get a nice average guy to tell what would be the perfect car for the average guy. And he's like, of course, you need like about 15 or 20 different car cup holders because I keep on putting a drink in, get another drink, and there's like now no more holders for it. So of course, it ends up being this train wreck of a thing that caters to nothing because it tries to cater to everything. So this is a lesson that we learned quickly with Azure Stack is being ready to say no. Jeffrey Snover, you might know of him, PowerShell fame. He talks a lot about these Jeffrey Moore value propositions. And this is something that we did in the very, very early stages of PowerShell. Now, the idea here is you say for this customer who, and what kind of customer this is, this product is going to do this certain value. But the key point about this statement is to be able to say, unlike this alternative, because there's a differentiator. So it ends up being kind of formulaic. But being able to truly answer these things and really get them down to this form lets you realize very quickly what are the unique values that you've got in this product you're making or this approach you're taking or this development that you're doing. Because if you know what these values are, then you can have a request come in. So for example, should we cut this feature? Should we add this feature? Hey, we have this request from this customer. You can very easily go against your values and say, no, this really goes against one of our core values, and that helps you really clarify what you're going to do. And I'll tell you, this has been a hard thing to be able to have customers who are saying, we love this idea of Azure Stack, but we want, and then like some little thing that's totally against the philosophies and the fundamentals of Azure Stack. So when you've got, $1 million looking in you in the face, and you say no, those are hard conversations, but you gotta be able to do it. So what this has meant is an amazing greenfield opportunity. We did not have any legacy support. We were able to say we don't have to worry about garbage in the infrastructure, it's from scratch. And we could do things like harden everything by default. We could assume breach and design everything for assume breach. Now, this is not Windows XP. Windows XP was not our driving philosophy for security, so you can feel safe and comfortable there. Now, one lesson that we did learn, though, is everybody talks about security basics. So hockey is this is the national sport of Israel, right? So one of the big things we learned, people talk about security basics like patching. But patching is not a basic. A basic is something that you learn once and you just kind of get over it, right? Like, can I tie my skates? There's nobody who's in the Olympics of skate tying. But compare that to things that they're required and they're necessary, but they demonstrate this huge range of skill. So stick handling, it's the act of taking a puck from one part of the ice to the other. Obviously, not everybody can do this. This is Patrick Kane. He's in Chicago. He's an amazing guy. This is not fake news. This is real, actual stuff. So realizing that there's a difference between basics and fundamentals, patching is a fundamental. It's hard. Making sure that everything is patched, whether it's up, whether it's down. Like, we got to stop shaming people about missing patches. But at that point, you can realize that there's going to be some stuff that people say you should do it, and realizing here as a lesson that you're going to have to spend a bunch of time making this work, just engineering time. So let's talk about some of the stuff we've done for secure by default and hardening. This from Lemmings, this is the blocker lemming. He just says, nope, nope, nope. Just block all the things. That's what he does. So this is the first stage of security, is just blocking all the bad stuff. Start, of course, with the hardware root of trust. People say you should do it. We did it. We got to work with OEMs and say we're going to use Secure Boot, UEFI, TPM 2.0. We could finally just say that this is going to be a requirement on all the hosts. So you don't have to worry about bootloader attacks and all that kind of stuff, aside from the stuff against this infrastructure itself. But you don't have to worry about bad rabbit stuff coming in and just doing super basic stuff against your infrastructure. Now, Jessica Payne, one of the things that we did learn, and we really lived by this in Azure Stack, is that Jessica Payne coined this of defenders can live off the land too, right? Everybody talks about attackers living off the land. But, for Azure Stack, when we're like, we want to secure this thing, what we didn't say is, all right, it's a shopping trip. Let's see how much we can buy to secure it all. All of this stuff is built into Windows. You just can go out, set up, and do it. Now, most people, you've heard of the term, you can only use 20% of your brain's capacity, and that is so true with technology. People end up buying some stuff, and they only use a little bit of it, and buy something else, and only use a little bit of it. Windows Server is absolutely that. So much capability is in there that people know is a best practice, and they end up just not doing it because they don't have the time or the expertise. But we did have the chance to do this in Azure Stack. So let's talk about the software attack surface in Azure Stack. Ton of baselines out there. We started with the DISA Stig, added and changed a couple things, but when you talk about the most secure and hardest baseline that exists, that's a great one to start with. And we could just go off and say, we're going to do this everywhere. We removed unused components, opted into all the security best practices, and here's the great opportunity we had. Because we sealed all the hosts incredibly, we could say we're going to be upgrading Windows whenever we want. We don't have to worry about some junky agent where we're not going to be able to go off and upgrade a version of Windows because it might do a bad thing. So we've done things like bring in the credential protection. We use code integrity and device guard everywhere. And of course, it's Windows, so it's got Defender and anti-malware installed everywhere. And well, some people are awake. Yes, no, we do not allow only NTLM. We have the opportunity here to know exactly our infrastructure. We can run our build and infrastructure and unit tests, and we can block all this garbage that you just want to get out of your system. The other big thing is around secrets and sensitive data. So for the secrets and sensitive data, of course, BitLocker everywhere. On the internal network, completely only allow TLS 1.2, Poodle and all those kind of stuff are protocol level issues that the industry has been trying to move away from for so long, but because we know exactly the internal infrastructure, we can just make these statements and then we can go off and do some tests. If anything breaks, well, then it's a change to the thing that's calling it, as opposed to having to try to work to some lowest common denominator. We can do strong authentication everywhere. We don't have to worry about old authentication mechanisms. And the big thing is that we can automate the secret rotation as well, because we don't have to worry at this point about, the biggest things are two things: people forgetting to rotate secrets. So you have certs or you have credentials that are stale and old. If any of them get stolen, you're in big trouble. So we can, for one thing, just rotate all that stuff. But then we can also say, we're going to automate the rotation of this in a way that minimizes downtime, unlike people who will rotate certs and not realize the impact, and then you've got huge, huge service outages. So we've been able to do that. But of course, that's not where it ends, right? You've got the ability to say, at some point, this presentation is evidence for the amount of effort we've put into securing Azure Stack. But also, you got to realize at some point, something will be compromised. You're going to have some issue in the portal, or some issue in storage, or something. So what can we do to assume breach and harden from there? The big change we made here is to say that Azure Stack, there are no Azure Stack administrators in the way that we talk about it today. Azure Stack has operators. Just like a customer using Azure proper, they go to the portal. Yeah, sure, they have administrative access over their subscription, but they can't access the fabric. They can't access the network. They can't do any of that stuff. So as a great example, let's talk about what it means when there is a support issue in Azure Stack. So what happens, we have this thing called the privileged endpoint in Azure Stack. So in Azure proper, there's just tons and tons of DevOps tooling that runs all the services inside. But what we've done for Azure Stack is to say, well, if we have an issue where product support needs to get involved in, well, we use just enough administration, PowerShell GIA. So this is an endpoint that the customer can connect to, and this operator endpoint that lets them do things like integrate it with their domain, extract some logs, the kind of stuff that a customer will want to do all the time. But if there's a big issue that needs access to the actual underlying fabric, we have a two-phase unlock protocol. So what happens is they log in, they start to run this one command to start the unlock process, and it generates basically one of two parts of a key. So then in coordination with Microsoft product support, they give their half of the key to product support. Product support goes to a very well-defended, protected web service inside of Microsoft. They enter the first half of the key, and that key is locked to that customer for a very short time window. That process generates another kind of a response token, so that way they can then give that back to the customer. And then there's a chaperone experience. So both product support and the customer get to see exactly what's happening in this support session. Everything is logged, everything is transcripted, and at the end of the support session, both parties get a log and a transcript of everything that happened. So it's a zero trust model in what's going on, where we would never want a customer's credentials that got compromised, we would never want that to turn into a fabric compromise. And similarly, no customer should ever have, Microsoft should never have persistent access to any customer infrastructure. And so this is the example of what we've done to make operators as opposed to the traditional administrator concept. Because here's the thing, admin privileges are the absolute enemy. They're the most targeted role that anybody goes after when they're trying to compromise something of any importance. There is a domain inside of Azure Stack, but nobody has access to it. Customers don't have domain admin. And when you explain that to them, like, you can see this like pale look come over their face, because they're looking at 15, 20 years of like just habit. They've got 14 organizations, everybody owns their own OU, all this kind of crazy stuff. They do not have domain admin to anything. what we've also done is I talked a little bit before about limit the interaction points. So just like Azure, you've got the portal, you've got ARM, which is the API surface, and then the third thing that we've added in Azure Stack is specifically the privileged endpoint that gives them ubiquitous transcripting. Now, what happens, though, when one of these nodes is compromised? Pretend that somebody compromises the portal, or they compromise one of the storage infrastructures. The goals here of us constraining this blast radius in the event of a compromise is to do things like prevent any lateral movement, apply the principle of least privilege everywhere, and then also use role-based interfaces for everything. So lateral movement, everybody says, hey, do good network stuff. Like, just be good on your network. What we've implemented is network whitelisting, where, and we've done it in 3 places, really. We've done it at the switch, we've done it at the internal SDN ACLs, and of course, we've got all the hosts with their host-based firewalls. This is a whitelisting-based approach, so all the hosts, all they're allowed to do is talk to things that they should normally talk to. So if you have one of these nodes that's compromised and somebody's trying to do some lateral movement, they're going to try spraying the whole IP address space that they can, but realistically, their next stage of attack are only machines that, for example, the portal should have been originally talking to. That does an amazing job at preventing this lateral movement. When it comes to principle of least privilege, everybody talks about in Active Directory, there's the group managed service accounts. So these are service accounts that are domain identities maintained by Active Directory, where computers have access to use that identity. But Active Directory does this amazing thing of rotating all that stuff for you. Now, by default, it's like 30 days. We're like, to rotate the credentials, we're like, let's make it an hour. We ended up finding some edge cases rotating creds every hour. So we've got like the creds in Azure Stack are rotated daily, which is amazing. Any of these things gets popped, that credential is only valid for a day compared to traditional models where you've got certs and accounts that are lasting for a long time. The other cool thing we've done is that none of these are part of domain admin groups. These are all just regular domain accounts, underprivileged, they're not admin to things. All they have access to are being used as an identity for connecting to other services that need to trust them. So now a receiving service, what it can do is just say, yeah, I understand this identity. I don't have to look in groups, highly privileged groups like domain admins. The other big thing that we've done is really lock down all interaction between components to not be administrative-based, but instead be task-based. So let me give you one example of this. There is a controller inside of Azure Stack, and its job is to manage the compute resources. So spinning up VMs, starting them, stopping them, all that kind of stuff. So in Windows Server, that's done through Hyper-V. Hyper-V has a great WMI interface to do everything that you want to do. But the issue with that is that those interfaces are exposed to admins. Now what that means is that the compute controller now has admin access to those VM hosts, and that's not what we want. So we made one pretty simple change, which is to move this across to, instead to use PowerShell as its connection mechanism, and instead use the Hyper-V PowerShell module. So now the compute controller is making a remote PowerShell connection, and it's using PowerShell commandlets, right? So once we made that one small change, made sure everything's working as expected, what we could then do is take PowerShell just enough administration. So PowerShell just enough administration says, for this PowerShell interface and this identity, it can only run the following 10 things. So what used to happen is this thing comes across using WMI, and now it's coming in as PowerShell, only able to do the things that it should do to manage VMs. No longer administrator. So it's just a great way of constraining identities. Anybody recognize this? Casey Smith, sub-T, he's presented here last year. This is a picture from BlueHat this year. So if anybody might be a code integrity, device guard, app locker curmudgeon, you might think it might be this guy. He has found more application whitelisting bypasses than I could think to imagine. But he's a great example of a pragmatist, and this is the big thing about taking that first step. So he got into the interesting area of application whitelisting and code integrity by doing security at a bank. He found that he was able to do a good job at reducing the attack surface by deploying app locker whitelisting policies to tons and tons of machines. Yeah, sure, he found some bypasses, he found some issues, but it is unquestionable that he was reducing attacks and danger and risk by an order of magnitude by deploying application whitelisting. And this kind of philosophy is one of the things that really drove us through all of Azure Stack. Is you can't let perfect be the enemy of the good. You can't say, well, there are known bypasses to application whitelisting, let's not do it. What you can say is, we're going to do it. Now, one of the things we did run into was, we'd have some situations. For example, we had an ASP.NET website in Azure Stack. We deployed code integrity, ASP.NET. When you run it, it does all this compilation of DLLs. Now, since they weren't signed and didn't work, that website failed to work. So what we did is we said, we're going to figure this out, but what we'll do is we're going to still deploy a whitelisted device guard policy to this machine, but we're just going to have a big exclusion list. And you feel so dirty when it happens. You're like, this is a exclusion list. This is a kind of a bypass that somebody could drive a truck through, but you're still solving the problem of people doing dumb things like dropping mimikatz and, as Spectre Ops like to say, like the unenlightened attacker, right? Just the base off-the-wall things. Once we had that exclusion, we could kind of work that problem. In ASP.NET, the answer is a precompiled set of DLLs, sign those things, and then it works, and you're great. And then you can get rid of that exclusion. But the important point is that this now gives you a list of things. Like, here are all the brutal hacks that I know of in the infrastructure that are preventing us from having a broad, something like application whitelisting. Then you can just work through those issues and just see yourself ratcheting up the security all in all. So if you can lock down a role, do it. Things like audit modes are your friend. Even still having alerts about application whitelisting issues are great. And of course, everybody talks about, like, what do you audit and all these kind of things? So Azure Stack has a default policy for auditing and intrusion detection. We configure this automatically. We generate it and centrally collect it. And then we give a REST API for third parties to interact with it. We don't use WEF because we have some other issues, but this is a thing where absolutely you can live off the land. Microsoft publishes a great resource out there of the event collection best practices that Microsoft itself uses. Inside of all of CorpNet, when you have an issue, they say, here is a good baseline policy. Here's another policy that you can apply when you've got a suspect machine. Here's a policy that you can apply when it's known to be compromised. You could take the same approach where you say, well, for Sysmon, for example, InfoSec Taylor Swift has this great master thing. Spectre Ops has been doing a great job of when, here's a thing you should look for, here's a snippet of a Sysmon policy that you can merge in and do this stuff. So we really took this to heart and made sure that all these things were configured by default and just by best practice. It wasn't hard. We just deployed, configured. We just decided to make that step. Here's an example from one of the folks that have interacted with us. This is Event Tracker. The idea here is that Azure Stack emits all of its logs into a storage account. They can then go against the storage account and scrape out the data and then apply their SEM knowledge to it. The one thing I'll point out, take a look at that second row. There's a code integrity violation. So this isn't that the machine got compromised. This is that somebody tried to run a single thing that didn't meet the device guard policy. Just imagine how much power that is. An attacker even just trying to use mimikatz, like the straight out of the box, it's not signed as part of the Azure Stack device guard policy, an attacker even tries something like that, and you've got a raging signal pointing out that, of course, Azure Stack is not going to be doing its own device guard policy violations. So you've got this raging signal that an attempt to run anything malicious on the machine now points to you that you've got an intrusion. The other thing that we've been able to do as part of all this, there's a cloud controls matrix that's been really, really useful. The great thing about standards is that there's so many, right? You've got PCI, HIPAA, FedRAMP, all this kind of stuff. Now, the cloud controls matrix, what it tries to do is to say, here are the actual base controls that all of these things call. What we did is we had a third-party assessor come in and go through the cloud controls matrix and say, yep, this thing, does it do it, does it not? And it kind of just goes through as this nice little checklist. And we're going to be publishing that cloud controls matrix because people will have their own standards, and then they can just quickly reference, hey, does it do this, does it do that? Because the big issue with standards is that one size never fits all. Now, the big point that we have, though, is that assessments, for sure, in the technology area, they can address all the infrastructure issues. But of course, they're never going to address that tenant layer where you've got VMs hosted in Azure Stack. They're never going to be able to assess the stuff you put into Azure Stack after it started. A lot of these things also talk about the people and the processes. Of course, the assessment can't go against those things. So that's the thing, that if somebody is looking for a formal assessment, basically this is the bootstrapper that helps get them along the way. You may say, like, Lee, that sounds all great, that's amazing, but what about the OEMs? How sick are you of seeing, like, that was great stuff, but then they had admin on a switch? Often the weakest link. We just decided to be pointy here. Every OEM that's shipping with Azure Stack, we're having engagements with them for threat modeling. We've required that every OEM get independent pen testing against the stuff that they're putting into their infrastructure, the stuff that they're doing. And also, these OEM patches are included as part of Azure Stack's monthly updates. One of the things that we can tell these operators is, we're going to train you on one thing, which is keep this thing patched. There's a monthly update cycle, schedule it, do it, it's all good. Now, we've trained them to do that, and all that OEM stuff goes through that exact same pipeline. And we had a really great answer here and a really great situation. So we had a OEM come back. They had this pen test done, and we had kind of a follow-up meeting with them, and you could kind of tell, like, their voices are shaking a little bit, and they're like, we don't really know how to say this, but we're just going to say it. Our pen test, they reverse engineered some firmware that we had, and now we've got a major security incident on our hands. So what had happened, this company has been shipping these switches for a long time, and from the process of acquisitions and all this kind of stuff, there was a company many years ago that worked very closely with a customer to do something specific for that customer, and turns out that, like, in that context, it made sense. But when you say that now this is going to, like, lots of people, it doesn't make sense. Now it becomes like a major security flaw, and this process helped them discover something that was industry-wide. As part of that pen test, they also found that they were relying on some open source software and some frameworks that had, like, super basic stack-based overflows, and they were able to then work with the open source framework, get those fixed, bring it in, and not only solve issues for Azure Stack customers, but all customers of those components. So in this situation, the OEMs are absolutely not the weakest link, and they've become, like, very, very strong proponents of what it's like to finally be able to say, we don't have to worry about customers screwing this up because it's all being done for them. So we've had, like, this really amazing infrastructure evolution. When you talk about very basic virtualization, you started with these general purpose building blocks, the OS and applications and frameworks. But what we've had people do is add on top of that custom processes, so the security and the updates and the management. But what you get out of that is duplication, inefficiencies, and usually security holes, right? People are saying we should be patching, but they don't, or it's like Joe's job and Frank forgot about it. But what we've moved to with this approach is to be able to say you can now certify a solution. Everything is well known. You also add in all the predefined and validated processes, security and updates and management, and that lets you do an amazing job at hardening things, and the result there is amazing security. But the point I want you to take away is to not buy Azure Stacks. It's, you can do this too. None of this stuff was rocket science. We did this, like our security team in Azure Stack isn't this massive team. As a defender, all this stuff exists in Windows. You can live off the land too. Realize that some stuff will require work. Don't feel embarrassed that it's hard to patch. It is hard to patch. Just do it. Start to realize that you're doing an infrastructure and do the work for really serving cake instead of the components. Have a point of view, be ready to say no a lot, and just take that first step. Thank you.